as it was mentioned, my name is Kyrylo Zakharov, and I'm CEO and CTO of startup legal tech startup Court on Nepal. And actually, our product is an analytical tool to search, explore, and visualize lawsuits. We had launched it in 2018, and a year later, we published the additional application Win Court. So, talking about this byproduct, this is the application that predicts the outcome of the lawsuit. Actually, how does it work? Any user can upload his or her document, whether it is a perfectly developed statement of claim or a simple description of the situation by the user's own words. Our application will find a set of similar texts of court decisions and will estimate the success of the litigation based on their metadata. Not only will it give chances of loss and wins, but also it will provide information about relevant to your case legislation, laws, codes, etc., the list of attorneys who participated in similar cases and their performance. And of course, our users will receive text of similar court decisions just to understand the possible logic behind the predicted outcome. Developing Win Court, we didn't use any overcomplicated technologies or like deep neural networks or cutting-edge AI approach. Our technological stack is much simpler and actually it is easy to explain. On the one hand, our users do not require high precisions because many lawyers do not believe to artificial intelligence. They want to clearly understand what is behind the prediction and so on and so forth. So actually, they require explainability of the received result. On the other hand, there is a lack of compelling datasets to train quite demanding AI algorithms. So in our system, we actually used Elasticsearch as a search system and an engine to provide recommendations to our users. Also, we use LangDetect plugin. It's a minor add-on to detect the language of court decisions. It's important because our courts use Ukrainian and Russian language in the legal proceedings, and we need to distinguish them in our data processing. This plugin uses a 3-gram character and a Bayesian filter with various normalizations and feature sampling to detect the language. Our sort tool is Tesseract. It is well known and a very popular optical character recognition tool. We use it to process documents uploaded by users in case if they upload images with text or PDFs without recognizing characters. Mostly in our data processing using with text, we use a set of rules based on regular expressions, a tool to work with patterns in strings, and we use Regex heavily to process court decisions in our dataset. And Bayesian approach with conditional probabilities is our general principle to make predictions about the lawsuit outcome. So during the development of Win Court, we faced a few challenges and made some steps to tackle them. First of all, our data sources. In 2017, Ukrainian State Judicial Administration published its archive of court decisions as open data. It was more than 1.5 terabyte of text in RTF and HTML formats, more than 80 million of court decisions. We don't use all of them, just 17 million for today, but actually amount of data is quite big and demanding for resources. A bit earlier, our Verkhovna Rada, the Parliament of Ukraine, published a comprehensive archive of the state legislation, more than 5 gigabytes of HTML data. And in 2017, it was clear that the open data community had received an invaluable source of data to create interesting applications. But nevertheless, our path was not easy, and we also met some issues. Namely, the lack of general data standards for legislation and court data. And also published metadata was not enough to be useful. For example, about court decisions, we got only data about region, about specific court and judge name, and only the date when the decision was accepted and published. So it's not a lot actually to create something interesting. Actually, the quality of data was poor, and I'm talking here about total data with a lot of mistakes. For example, we found latent symbol in Cyrillic strings and vice versa. Some entities did not have unique identifiers. For example, names of judges was only in like strings without unique identifiers. Um, some data was inconsistent. In the same dataset, name of judges can consist of surname and initials, initials and surname, duplicated initials or surname only. And also there was a lack of labeled data to train any algorithms. You know that the most fruitful algorithms can be trained with supervised learning, but we were not able to do this. So we needed to conduct initial research, process and summarize data, um, create our own data sets, invent some kind of our own identifiers for data, and so on and so forth. So during this work, we created our own register of Ukrainian judges, the classification of lawsuit outcomes, data models for lawsuits, and legislation. So data processing. I've told you that we used regular expressions heavily, and it was clear that the key arguments and litigations are related to legislation citings. So we developed a set of algorithms based on regular expression, first of all, to fix typical mistakes and normalize the text of court decisions. We unified punctuation, we converted numbers and words to numbers, we lemmatized words, and so and other. We split state laws and codes into article, paragraphs, and items, and each of them is stored as separate entities just to be used in our following process. And also, we find with our algorithms legislation citings in text or court decision and store this information as a lawsuit metadata. So all extracted data is stored in separate databases in Elasticsearch. So our users can use the search system with full text search and filter results by specific cards, judges, or legislation used in case. But as I told, we also try to predict the outcome of lawsuits. And actually, we use some specific kind of queries provided by Elasticsearch. Elasticsearch provides a special type of query called more like this query. It finds documents that are like a given set of documents or a single text. To do so, MLT selects a set of representative terms of these input documents, forms the query using these terms, executes the query, and returns the results. Therefore, the terms of the input documents that have the highest TF-IDF score, it's term frequency divided by inverted document frequency, and these scores are good representatives of the document and could be used within the disjunctive query to retrieve similar documents. So the multiquery simply extracts the text from the input document, analyzes it, usually using some kind of analyzer, including lemmatization of words, cleaning punctuation marks, and so on and so forth. And then it selects top key terms with the high CFEDF to form a query of these terms. Additionally, a multi-query can receive different parameters related to terms, like minimum term frequency, max query terms, mean and max word lengths, some exclusion of stop words using specific analyzers, and some of parameters also very useful for finding similar text, like parameters minimum should match, how much your text must be similar to other court decisions, and you also can boost some terms if you want to tune your prediction. So this multi-query finds similar court decisions, aggregates their metadata, and provides all relevant statistics. Additional tuning, we allow our users to define the value of minimum should match parameter and get more broad but stable estimate based on bigger corpora of text, or select the less amount of text and get more specific results. Additionally, our users can restrict the forecast by selecting decisions of specific courts and select the time frame. Another thing to mention is changes in legislation. During the forecast, we would like to avoid using court decisions with outdated laws. So by default, our algorithms detects relevant to the case legislation and correct the data frame to fit the latest updates in it. So, results. I'm going to show you how does it work, and then I will answer some questions. To achieve this, I prepared a few different texts. I will show you them right now. So the first one can be translated this way. The boys in the yard beat their peer and took away his phone. So you see, it's a very simplified description of possible crime, and we want to have some legal advice. What legislation can we use in this case? What is the probability that we will win the claim? So we can visit the site of Court on the Plum, select Twin Court Service, and upload this file to our system. Then we use our prediction. We want to find all texts that are similar at 18% similarity and push the prediction button, and we get the result. And we can see that only 30% out of 355 court decisions include the satisfied claim. So it won't be an easy task to prove the committed crime. Also, we can review the information about different attorneys who work in similar cases, who participated in similar cases. And also we can review the legislation section. And we can see that this is a criminal case. And most of all, in different court decision was used the crime code and code of criminal procedure. And also we can review some proposed articles. So first of all, we can see that this was not a single crime, but a bunch of crimes at the same time. We can review Article 185, and we see that this crime is related to theft. Also, we can see other articles, and we see that it's also related to possibly to burglary or let me translate this, robbery with aggravating circumstances. We can try another text. For example, the second text can be translated this way. The company has debts, but it hasn't paid off for 3 months. So this is very different situation, but again, it's described in very simple wordings, and we can try again to use our algorithms and try to understand something about our case. So we upload this text and try to make similar prediction. So we can see that there are much more court decisions, and the probability to win the case is much higher. Also, we can see a lot of attorneys, and we see that most of claims are satisfied, and amount of partially satisfied claims isn't big enough. Also, we can review the legislation and see that this is a civil case, and we can review the articles of civil code, and we will see that this case is related to the responsibility of liability for breach of a monetary obligation. We can see that judge will review everything about conditions and terms of the obligation and possible consequences, including fines and penalties. So just using our system, we can see everything related to the case and make our own forecast of possible case outcome, receive the first advice on legislation to use in legal proceeding, and even we can see similar court decisions just to understand what arguments will be useful for judges or in our case. You see, we created a bunch of algorithms to extract all named entities in our data and also review any linked data just when you see the text of court decision. But this is not our final stop. We're going to develop our system further, and in the near future, we're going to create a compelling deduplicated corpora of court decision to train our own Ukrainian legal word embeddings to improve our algorithms. And we're going to try to handle new tasks, like, for example, estimate the probability that the counterpart will try to appeal or go to the cassation court. To predict the probability of winning an appeal or cassation court, we want to build algorithms which will be useful to found some parsing text with arguments and court decisions, and much, much more. So I think this is everything I want to share. Thank you for your interest.